Alright, so in this example we can see we're given 2 points. We're given points A and B, and we're given some expression for the combinations of A and B here. So when we've got points, a useful strategy might be to draw a diagram here to get a visual representation of what's happening in the problem. So we could say, well, we don't know exactly where A is. It could be here, let's say. A is 0. We know it's definitely on the x-axis because the y value is 0. Maybe B value is here. B, 0. But there's no reason why A has to be smaller than 0. Perhaps A is bigger than 0 maybe. Bigger than B. But what we do know from the question is that it's a unit vector. So either way we talk about it, this distance here between A and B must be equal to 1. And we've studied a function that does this exact same thing. That's right, it's the absolute value. If we take the difference of the 2 points, regardless of which is larger, we know that if it's a unit vector, that distance has to be equal to 1. So solving this, we'd say, taking the positive value, A minus B could be 1, which would give us A equal to B plus 1. Or we could say that A minus B is minus 1. Or you could take the negative of the left-hand side, but the algebra works out a little bit easier here. So we can say B minus 1. So now we can substitute that into our expression up here, A plus B equals 17. So given A plus B is 17. Now if we substitute this here for A, we'd say B plus 1. So here we have the expression B plus 1 substituting here in for A plus B is equal to 17. Simplifying this, we'd have 2B subtracting 1 to be 16 and B would be 8. So by remembering that we need to substitute back into our original expression, we would have A equal to 8 plus 1, so A equals 9. So there's one possible solution, but we should also now substitute in this value B minus 1 into the expression we were given, A plus B equals 17. Instead of A, we'll have B minus 1 plus B equal to 17. So we have 2B equal to 18, B equal to 9. And when we substitute this back in here, we'd say 9 minus 1, A could be equal to 8. So there are 2 possible combinations for A and B here.